1871, Dmitri Mendeleev's periodic table was presented to the world, but missing many of the 118 elements that we have today. His indigenous design perfectly organized the elements based on similarities in their properties, leaving placeholders for those as of yet undiscovered. Each element added since then has a unique story of scientific discovery and to honor. Women have contributed to the chemical science since the age of alchemy, but for centuries they did so largely unseen and unheard. Today, we wanted to share the story of chemistry's most brilliant and bold women and their path in elementary discovery during 19th century because what they brought to the table changed the world. Marie Curie. In 1896, legendary scientist Marie Curie had a breakthrough discovery while studying uranium. By using a tool called an electrometer, she was able to detect electrical charge in the air around a uranium sample, and later in samples of minerals containing uranium. The higher the concentration of uranium, the more charged the air. Her findings led her to hypothesize that radiation didn't come from particular combination of elements, but rather from specific types of atoms themselves. She made a survey on each element of the periodic table in addition to many different minerals. By 1897, she had concluded that uranium and thorium were the only non radioactive elements, with uranium being the most radioactive element. While continuing her survey on minerals, she discovered 5 times the radioactivity of uranium in a sample called pitchblende and twice as much in another called torbanite. This meant that there had to be another source of radioactivity, and her hypothesis was correct: a new element. By 1898, the duo had surveyed enough samples to confidently pronounce the discovery of 2 new elements, polonium and radium. Marie Curie and Pierre Curie tried to isolate these elements in the lab because they exist in such small quantity in nature. They would need tons of materials to be able to extract them in measurable quantities. As she worked by hand with samples weighing over 40 pounds day in and day out, and slowly purified the ore and get rid of the sand, clay and other materials in the ore. After 3 long years of back-breaking labor, they were left with 1 decigram of radium chloride, enough to determine an atomic weight of 226. Mary earned the honor of Nobel in chemistry for her elemental discovery. Her tenacity and genius were later memorized with the discovery of element 96 in 1944, which was named curium in Mary's honor. Margaret Perry. Margaret Perry discovered the chemical element francium in 1939. Francium was the last element ever discovered in a natural source. All elements discovered after Perry's discovery have been produced by artificial method in the laboratory. She applied for work in Marie Curie's laboratory in Paris, the Radium Institute, and was amazed to be interviewed by the great Marie Curie herself. This could have been an intimidating experience for the 19-year-old girl, and indeed, the interview seemed to go badly. However, Perry was surprised to learn she had been hired. She was going to work alongside Marie Curie. After starting work at the Radium Institute, Perry was trained in the isolation and purification of radioactive elements. In time, she became responsible for preparing and purifying samples of chemical element actinium. The discovery of francium. In 1935, aged 26, Perry read a research paper from the USA. The American researchers had found beta particles being emitted by actinium. Perry knew as much about actinium as anyone else in the world. She had been working with it for 7 years. She decided the American researchers were probably wrong about actinium being the source of beta particles. While actinium did emit beta particles, Perry thought the energy of the beta particles seen in America was wrong for actinium. Perry decided to produce an ultra-pure sample of actinium and study its radiation before it has the chance to form daughter products. The ultra-pure actinium sample would have to be prepared and its radiation studied in a very short time frame. Perry discovered that actinium could decay by emitting a helium nucleus from its own nucleus. Such a helium nucleus is called an alpha particle. The daughter nucleus formed was previously undiscovered element which she chose to call francium. After some discussion, Perry decided to name the new element to honor her home country, France, and so a new element was added to the periodic table, francium. With her PhD, Perry immediately became a senior scientist at the Radium Institute. She continued working there until in 1949 at age 40. She took the chair of nuclear chemistry at the University of Strasbourg. Perry also served as a member of Atomic Weights Commission between 1950 and 1963. In 1962, she became the first woman to be elected to the French Academy of Sciences. Margaret Perry died at age 65 on May 13, 1975. Like Marie Curie and a number of other scientists who had worked at Radium Institute, she died of a radiation-linked illness. In fact, her body was found to be unusually radioactive. She had been instrumental in the introduction of the better safety measures in the laboratory under her control. Sadly, this was too late to save her own life, but it was a lifesaver for future generations of nuclear scientists. Lisa Meitner. German physicist Lisa Meitner, together with Otto Frisch, was examining data from Otto Hahn and Fritz Strassmann, who had been lab colleagues before having been forced into exile by Hitler. When bombarding uranium with neutrons, Meitner found that barium could only be produced if the neutrons split uranium into two pieces. When describing this process, she became the first scientist to use the term fission in a nuclear context. The Manhattan Project, which inaugurated the modern era of chemistry and allowed for a new layout of the periodic table, might never have happened had word of Meitner's discovery not reached scientists in the United States in January 1939. Meitnerium, atomic number 109, named in honor of Lisa Meitner. Ida Noddack. In 1925, German chemist Ida Noddack and two colleagues began their search using X-ray spectroscopy and by chance found a previously unknown metal. They called it rhenium, element 75, from a mineral called Norwegian columbite, and its name is derived from the Latin name for one of the longer river, Rhine River of Europe. But the scientific community pushed back on their publications, so they would need to isolate samples in the lab, and they successfully isolated rhenium in high enough quantities to be verified. Now you will find rhenium in many places in the Earth's crust, but always in very moderate amount and always attached to more profile metals. But rhenium is a very important assistant added to the chemical compositions of, for instance, protective coatings that can make ordinary metals product. all of a sudden resistance to extreme high temperature